All right, so 3.3 slash 3.4. First thing we're going to talk about is change of base formula. So we kind of talked about we can put logs into the calculator, but a log just does the common log. It doesn't give you an option to change the base. We can put log of 25 in the calculator. You'd get 1.397 if you did this. It doesn't give you the option to change the base. It only does common logs, which is when your base is 10. So if we had the base of 10 every time, that'd be perfect. We can just throw it in the calculator, but that's not going to be the case. Our base isn't always going to be 10 when we do those. So if we have a log with a different base that's not 10, we're going to use our change of base formula. So to put this in the calculator, we're going to do the log of 25. So the big number goes on top, the base goes on the bottom. So think base, bottom. So then we have log of 4 on the bottom. We're going to put this into the calculator. Be careful when you put it into the calculator. Most calculators would do log of 25 and open a parenthesis here. You have to make sure you close the parenthesis before you divide it by the log of 4. So just be careful when you put this into the calculator. When I do the log of 25, I'm going to close the parenthesis and then divide it by log of 4. So you should get 2.3219. We're going to do the same thing for B. So we're going to take the log. What would go on top? Log 12 over log of 2. So log of 12, I'm going to make sure I close the parentheses, divided by log of 2. So you should get 3.5849. Some calculators do let you change the base. So if you have a super smart calculator and you can change the base, you can do it that way. But most calculators don't, so you have to do it this way. You can also change the base using the natural logs. So same thing works, but natural logs are ln. So we would take the ln of 25. Again, the base goes on the bottom. So divide it by the ln of 4. When we put this into the calculator, ln of 25, close the parenthesis, divide it by ln of 4. You'll get the same answer that you do if you do the log. So 2.3219. So it's the same thing that we got up here. Again, for B, we're going to do the same thing, but the ln. So we can do the ln of 12 over the ln of 2. You'll get the same answer. ln of 12, close the parenthesis, divided by the ln of 2. We'll get 3.5849. So same thing we got up here. Next, we're going to talk about properties of logs. So properties of logs are super important. Lucky for us, we've seen this in Algebra 2. Same properties that we're dealing with here. So if we take the log of two terms that we're multiplying together, we can split it up with addition. If I had the log base 4, let's say, of 2x. 2 is being multiplied to x, so I can split these apart and say log base 4 of 2. Multiplication goes with addition, so I'd say plus, and every time we split it apart, each one gets its own log, and the base stays the same. So log base 4 of x. So these are the same thing. We can expand it with addition. So multiplication goes with addition. If you have logs, same rules apply for if you have ln's. Same thing. Next, we have the quotient property. So quotient is the same, but just when we're dividing, we subtract. So when we're dividing, we subtract. If I had the log base 6 of x over 5, we would split this up as the log base 6 of x minus the log base 6 of 5. Every time we break it apart and expand it, each one gets its own log. Same things happen if you have ln's. Same rules. Last property we have here is the power property, if you have the log to an exponent, you can move that exponent in front of your log and it becomes a coefficient. So if I had something like log base 5 of x to the second power, I can take that x and move it in front of the log. So this would be 2 times log base 5 of x. So the exponent turns into the coefficient. These properties work both ways. If we were condensing our log and we had addition, we can condense it together to be a single log with multiplication. So you can go either way. Let's look at example 3. We want to write each log in terms of ln of 2 and ln of 3. So we want to split 6 apart, either with multiplication, division, or exponents using 2 and 3. How do you think I can make 6 using 2 and 3? How do you think we can make 6 using 2 and 3? With like multiplication. Multiplication, we can multiply 2 times 3. So this ln of 6 is the same thing as saying ln of 2 times 3. We're not changing the value of 6, we're just changing the way that it looks. Now if I have 2 times 3, I'm multiplying. How could I break this apart into 2 separate ln's? What goes with multiplication that we talked about up top? Adding. So I could split this apart and say the ln of 2 plus the ln of 3. So this would be our answer. This is how we write each log in terms of ln of 2 and ln of 3. That's what it's asking us for here. Now for B, we're going to do the same thing. We're dividing, and it already gives us a 2 on top, so we can leave that. But how do I change 27 to be in terms of 2 or 3? 9 times 3 works, but we have a 9. So our goal is to only get it in 2s and 3s. What else could we do? 3 to the power of 3. Awesome. So this would be ln of 2 over 3 to the power of 3. Well, if we wanted to break this apart and we're using division, what would we do? What goes with division? Subtraction. So we'd take the ln of 2 minus the ln of 3 to the third power. Now when we have an exponent, what would we do? What do we do with our exponent? Move it in front as a coefficient. So we're going to put it in front of that ln that it's attached to, not in front of the whole thing, just the ln that it's attached to. So here we have ln of 2 minus 3 ln 3. So on the next page, we're going to expand using our properties. So we're going to break it apart. Each term is going to get its own log. In A, what are we doing between the 5, the x cubed, and the y? Multiplying. What goes with multiplication? Addition. So we're going to break them apart using addition. So we have log base 4 of 5 plus, every time we break it apart, each term is going to get its own log. So log base 4 of x to the third power plus log base 4 of y. Now if we have an exponent, what would we do with that? Put it in front of the log that it's attached to, and it turns into a coefficient. So this turns into log base 4 of 5 plus 3 log base 4 of x plus log base 4 of y. So your goal when you're expanding it is just to get a single term in each log. So this would be our simplified expansion. Any questions here? Yes. Yeah. That's the second part of this lesson, but I think we're going to save those for tomorrow. But it would be like an equation. It'll have an equal sign, and we'll talk about strategies on how to solve it. Any questions? Good here. We're going to do one more. I'll call it C. So let's say we had log base 2 of x over y times z. So with questions like this where you have multiple terms in your denominator, we're actually dividing z and y and z. So when we split this up, we're going to say log base 2 of x. What goes with division? Subtraction. So minus log base 2 of y. What would come next? Just z. Minus log base 2 of z. So because both of these terms are on the bottom, they get a minus. So even though sometimes people think like y is being multiplied to z, a common misconception would be z gets a plus because you're multiplying it, but z is still being divided. It's in the denominator. So anything that's in the denominator gets a minus. Anything in the numerator would get a plus. Yes, yeah. Let's look at example 6. So we're condensing our log. So our goal is to condense it down to be a single log expression. We want one log in our answer. What do you think we would do first for A? Let's change our coefficients to be exponents. Perfect. So we're going to put this on top of the log that they're attached to. Oops. So this one's going on top of the x. The 3 is going on top of the x plus 1. So here we have log base 10 of x to the 1/2 power plus log base 10 of x plus 1 to the 3rd power. Do I need to write the 10 there in my answer? Do we need to write the 10 in our log? 10 is the common log, so if it's not there, it's the same thing. If you had log base 10, you could rewrite it just as log. That's fine too. So you could not even put the 10. It's like saying like square root is the same thing as the square root. Oops. Like that. You don't really need it. But we can leave it there. It's fine. Let's see. What else can we do to condense this? Remember, our goal is the single log. So how can we combine these together? What goes with addition? Multiplication. So we're going to combine our logs together by multiplying what we're taking the log of. So log base 10 of x to the 1/2 power times x plus 1 cubed. Now we could also write this as log. Remember we said we don't need the 10, so we don't need to put it. How could we say x to the 1/2 power? What's a different way of writing that? The square root of x times x plus 1 cubed. So this would be like our most simplified version. I'm not sure if WebAssign would take the 1/2 power, if it would want you to change it to be the square root of x. But they go both ways. Super, super important to know that x to the 1/2 power is the same thing as the square root of x. When you're simplifying it, or when you're, expanding it, it'll want you to change the square root to be the 1/2, because then you have to move your coefficient and make it a coefficient. So super important to know. What if I had the cubed root of x? What would this be? Olivia? X to the 1/3. Awesome. So again, these are important to know. Next, let's do B. I'll do it over here. What would we want to do first? Change the coefficient to be an exponent. So we're going to put it on top of the log that it's attached to. What else could we do? We'll do 2 steps in one here. What goes with subtraction? Division. So we're going to divide. When we condense it down, we're condensing it to a single log or single ln here. So ln On top, we have x plus 2 squared over, what would go on the bottom? Just x. Awesome. So this would be our answer. Questions there? All right, perfect. Let's do C. So C, we've got a coefficient in front of brackets. So it's technically a coefficient of both. We could distribute this to our two logs inside. So the first log would have the exponent of 1/3, and our second log would have the exponent of 1/3. So because it's outside of the bracket, it goes to both of them. So this would be log base 2 of x to the 1/3. How else could we write the 1/3 power? What did we just say? The cubed root of x plus log base 2 of, again, we have the 1/3 power, so we'd say the cubed root of x minus 4. Now when we're adding, what goes with addition? Multiplication. So we could say the log base 2 of the cubed root of x times the cubed root of x minus 4. Since these are the same index and the same radical, we can combine them together to be log base 2 of the cubed root of x times x minus 4, like this. So you could have combined them first. So you could have combined them with addition first, and then dealt with that 1/3 as a coefficient at the end. But either way works. But if you have the same radical, you could put them together. So this would be our most simplified answer. So up here, this is kind of 3.4 notes. We start with solving using our exponential and log functions. So we've got some more properties up here. We've talked about the one-to-one property. So if we want to make our bases the same, we can cross off the bases, set the exponents equal to each other. Same thing works if our logs are the same. If I have log base 4 of x equals log base 4 of 8, the logs cancel, and I can just set what I'm taking the log of equal to each other. Again, same thing with the ln. If you have the ln, one ln equals another ln, you can cross them off. You can't just cancel them out. If I had something like log of x plus log of 2 equals log of 10, you can't just cancel out all the logs here. Doesn't work that way. We could combine these together to be a single log. How would we combine them together? What goes with addition? Multiplication. So we'd say log of 2x, because we can just multiply them together, equals log of 10. Now that we have a log equals a log, they can cancel. So it only works if you have a log equals another log. D is the same thing, same base, we can cancel them. If you have, so these are inverse properties from E to F. If we have an exponent where x is in our exponent, we use logs to get it out of the exponent. If x is in a log, we're going to use exponents to get rid of it. So here, ln and e will always cancel each other out. So in step E, we would take the ln of both sides. Ln of e is just 1. They cancel, so we're left with x equals the ln of 7. We would just put the ln of 7 in our calculator. For f, since we have an ln, I'm going to use exponents to solve here. So ln goes with e. So I'm going to make my big base e. So e to the power of ln will cancel, and I'm left with x equals e to the power of -3. So I used exponents when I have logs so that -3 becomes an exponent. Same thing in h and g and h. If we have logs, we're going to use exponents. So I'd make my big base 10 here, whatever the little base is. So I'd make the big base 10. 10 to the power of log base 10 will cancel. We're left with x equals 10 to the power of negative 1. Same thing with h. What would I make the big base here? 3, whatever the little base is. So make the big base 3. 3 to the power of log base 3 will cancel. We're left with x equals 3 to the power of 4. So these are like the building blocks. This is the fundamentals that you got to understand that you can do in order to solve. So these are inverse. If you have logs, you use exponents. If you have exponents, you want to use logs. All right, so it gives us strategies for solving. So it says rewrite the original equation in a form that allows you to use the one-to-one property. So if you can use the one-to-one where you get a log equals a log, or the bases to be the same, that's what you'd want to do first. Then if that doesn't work, you'd rewrite an exponential equation in log form and apply the inverse property, or you'd rewrite a log equation into exponential form. So we do the inverse. So let's look at example 2. So here I can't make the bases the same. So since x is in my exponent, I have to use logs to help me. Well, what cancels out with an e when my base is e? ln. So I'm going to take the ln of both sides. So ln of e cancels. ln and e cancel each other out. So we're left with x equals the ln of 72. So then we're just going to put this into our calculator. ln of 72. You should get x equals 4.276. Now we can only use the log property or the inverse property once that base is isolated. So for a question like B, we want to get the exponent part to be all by itself first. So how do you think I could move that 3 to the other side? Divide. Perfect. Since 3 is being multiplied, we're going to divide both sides by 3. So it'll cancel out. So we have 2x equals 42 divided by 3. So that would be 14. Can I get my bases here to be the same? Oh, yeah, x should be in the exponent here. Sorry. So 2 to the power of x equals 14. Can I make 14 be 2 to some exponent? No. So what do we have to use here to solve? So if we have an exponential function, what's the opposite of exponential? We're going to use logs here. So if x is in your exponent, you can't get the bases to be the same, you have to use logs. So we're going to take the log of both sides. Whatever the base is that has the exponent, that's going to be the base of our log. So log base 2. Whatever we do to one side, we have to do to the other. So we're going to take log base 2 of both sides. Log base 2 of 2 cancels. So we're left with x equals log base 2 of 14. So x equals, how would I put log base 2 of 14 in the calculator? Awesome. Log of 14 divided by log of 2. So when we put this in the calculator, we're going to do log of 14, close the parentheses, divided by log of 2. We get 3.807. So that would be our answer. Let's do 3. So just like before, we want to get the base with the exponent isolated. We want to get it all by itself. So what should we do first here? Awesome. Add 3. Let's move it to the other side. So 4e to the power of 2x equals 5. What would we do next? Divide by 4. So e to the power of 2x equals 5 over 4. Now, what would we do to get x out of the exponent? ln, awesome. We use logs. More specifically here, since our base is e, we're going to take the ln of both sides. So ln of e will cancel. We're left with 2x equals the ln of 5 over 4. So in my calculator, I'm going to do the ln of 5 over 4. So we get 2x equals, I'm going to leave this answer in my calculator because it's a long decimal. So we get 0.2231435. It keeps going, but I'm going to leave it in my calculator. What's the last step that I have to do to get x all by itself? Divide by 2. So x equals, in my calculator, I'm going to take that answer and divide by 2. So we get 0.1115. I remembered what I was going to say. Make sure you know how to use your own calculator. It happened to some people on the quiz where they had to borrow a calculator from a friend and they asked me, how do I put an exponent in this calculator? I told you, I warned you, I'm not going to teach you how to use a calculator the day of the test or quiz. So it's super important with these questions, practice using your calculator. Make sure you know how to use your own calculator. Come time for the test and quiz. Do the homework with your calculator. If you don't have a calculator, go buy one. All right, so example 4 is where we left off. So we're still solving. If we have an exponential equation, we're going to use logs to solve. If we have a log equation, we're going to use exponents. So here, just like we were doing yesterday, we want to isolate the base with the exponent. So we're going to isolate what's in the parentheses here. What would we need to move to the other side first? 4, so we're going to add 4. So we have 2 times 3 to the power of 2t minus 5 equals 15. What would we do next? Divide by 2. So 3 to the power of 2t minus 5 equals, we can call it 7.5, or if you just wanted to leave it as 15 over 2, that would be okay. What would we need to do next? How do we get rid of the x or the t from the exponent? If we have exponents, what do we use to solve? We're going to use logs to solve. What's the base of my log going to be? 3. Whatever the base of your number with the exponent, that's going to be the base of your log. So we're going to take the log base 3 of both sides. So log base 3 of 3 cancels. We're left with what's in the exponent here. So 2t minus 5 equals log base 3 of 7.5. How do I put log base 3 of 7.5 in the calculator? What goes on top? Log of 7.5 over log of 3. So we have to do this in the calculator, then we can isolate the t. So you'll get 1.834. It keeps going, so leave it in your calculator. If you do it separate and take it out of your calculator, I guess, and want to retype the whole decimal, make sure you include all of the decimal places. What would we do next? Add 5. So we get 6.834. It keeps going, but we're going to leave it in the calculator. What's the last step? Divide by 2. So t equals 3.417. Let's do example 6. So here we're going to solve the log equation. So we're going to use exponents to help us. Well, what will cancel out the ln? E and ln cancel each other out. So we're going to make the big base e. Remember, we said we have to use exponents if we have logs. So we're making the big base e. So e to the power of ln will cancel. We're left with 3x equals e to the second power. So that e is our base, and whatever was there is our exponent now. So we're going to put e to the second power in our calculator. You should get 7.389. It keeps going, but we're just going to leave it in our calculator. What's the last step? Divide by 3. So x equals 2.463. All right, what about for b? What would we do for b? If we have a log equals a log, what can we do? Cross them off. And then we just set what we're taking the log of equal to each other. So 5x minus 1 equals x plus 7. Then we just solve for x like normal. So subtract x on both sides. And we can add 1 to both sides. So 4x equals 8. And divide by 4. So x equals 2. So example 8. So just like before when we had exponential equations, we needed to isolate our exponent. We have to isolate our log. We need to get the log all by itself first before we can use our inverse. So how would I move that 2 to the other side? We can divide by 2. Another thing that we could do here is you can make that 2 an exponent. So it'd be 3x to the second power. But be careful, if you do that, it would be like 3 to the second power and x to the second power. You can do it, you'll get the same answer, but I think it's just easier to divide it, get it out. So they cancel. We have log base 5 of 3x equals 2. Now I have logs. How do I cancel out the log? What's the inverse of logs? No. The inverse of logs would be exponents. What would I make the big base here? 5. So we make the big base 5. 5 to the power of log base 5 cancels. So we're left with 3x equals 5 to the second power. So my base is 5. The 2 becomes an exponent. Yes?
Could you do how we did in the last lesson? We would do 5 equals 2 equals, 5 to the second power equals 3x. Like move it to exponential.
Yeah, it's the same idea, same thing. You get the same. So if we have log base 5 of 3x equals 2, and we rewrote this into exponential form, we'd have 5 to the second power equals 3x, which is the same exact equation that we got here. So you can do it that way. If you like to think about it that way, totally works. Then from here, we have 3x equals 25. What's the last step? Divide by 3. So 25 divided by 3. We get 8.333. So last one, example 9. So we said if we have a log equals a log, we can just cancel out the logs. Same idea with the ln. If we have an ln equals an ln, we can cancel them out. But here we have 2 ln's on one side. How do we condense it down to just a single ln? What goes with addition? Multiplication. So we have the ln of x minus 2 times 2x minus 3 equals, how do I get this ln all by itself and get rid of that 2 in front of it? Because I don't just want to divide it to move it to the other side because I don't have a number on the other side. What could I do with that 2 that's a coefficient right now? Make it an exponent. So I'm going to put that 2 on top of the x. So this is ln of x squared. Now that I have an ln equals an ln, I can cancel them out. So we get x minus 2 times 2x minus 3 equals x squared. Now we want to solve for x. So I'm going to have to FOIL the left side. So we get 2x squared minus 3x minus 4x plus 6 equals x squared. So 2x squared minus 7x plus 6 equals x squared. What would we have to do next? What should we do next? Subtract the x squared. We want to move all of our terms to one side because when we see we have an x squared, we know we're probably going to have to factor. So here we have 2x squared minus x squared would be x squared minus 7x plus 6 equals 0. So if you're going to factor, you need it to be equal to 0. Since we have an x squared, we have to factor. So it's perfect that all of our terms are on one side. Let's factor it. What are two factors of 6 that add to negative 7? Negative 6 and negative 1. So x minus 6 and x minus 1 equals 0. So x equals 6 and x equals 1. Now, when we're dealing with logs and ln's, we have to check for extraneous solutions. It said it in the heading here. Check for extraneous solutions. So especially when you get two answers, you want to check your answers to make sure that they work. Let's kind of think back, maybe not the first part of this lesson, but maybe in the first part of the chapter. What could we not take the ln or the log of? Can't take the ln of a negative, and you can't take the ln of 0. If you put the ln of 0 in your calculator, it'll tell you error. If you take the ln of a negative number in your calculator, it'll tell you error. So you can't take the ln of a negative, and you can't take the ln of 0. So we want to check our answers. So we have to check here. Let's check them and see if they work. So first I'm going to plug in 6. So you don't have to plug it in and work it all out all the way. Just make sure you're not taking the ln of a negative. So 6 minus 2 would be 4. That's positive, so it works there. 6 times 2 is 12. Minus 3 would be 9. 9 is positive, so it works there. And then ln of 6, 6 is positive, it works there too. So 6 works as an answer. It works in all of our ln's. Next, let's check 1. So I'm going to do the same thing. I'm going to lightly plug in 1 here. What's 1 minus 2? Negative 1. Can I take the ln of negative 1? If I put the ln of negative 1 in the calculator, what do we get? Error. It does not work. So 1 would be an extraneous solution. So our only answer here is x equals 6. So when you're dealing with your log equations and ln equations, you can't take the log or an ln of a negative. So you have to check your answers.